This time we'll look at a 24-pin G11 design, a smart moisture sensor with Bluetooth low energy connectivity. What is smart agriculture and smart produce monitoring? Moisture monitoring is key for precision irrigation, enabling growers to produce higher yields of better quality crops while conserving natural resources. Smart produce might include monitoring moisture levels on the store shelves to avoid drying out or over-moisturizing produce at the market. Observe the time water misting in the produce section. In this design, 3 different selectable resistors are switched in one at a time dynamically to measure a wide range of soil resistance. This is done in conjunction with the programmable gain amplifier providing amplification to the ADC analog input. The RL78 G11 handles all the sensor edge processing and manages 4 different activities. A buzzer output to the alarm if the soil gets too dry. B, solenoid motor control to turn a water valve on and off, and to drive the motor bidirectionally through a DC motor H-bridge driver. The RL78 G11 timer KB0 could be used, which also provides dead band output timing. C, communications to the RL78 G1D Bluetooth low energy RF transceiver when the moisture level goes out of high or low range. D, wake up timing for sampling moisture levels and other periodic events. The RL78 Smart Moisture Sensor hardware implements a G11 in small 4mm square QFN surface mount package. It also incorporates a RENESAS RL78 G1D Bluetooth Low Energy Module RY7011A with PC board antenna included in a 8.95mm by 13.35mm footprint with surface mount solder contacts. This Bluetooth Low Energy RF transceiver can be used to transmit moisture information to an Android or iOS phone. We should note that to keep the sensor size small, only a single 1.5 AA alkaline battery is implemented. Therefore, a DC to DC boost converter is used to provide a constant 3.3 volt supply to the MCU. When the MCU is in stop standby mode, it only draws 0.35 microamps typical. The no-load quiescent current for the boost converter is 5 microamps typical and 7.5 microamps max. Even if we use a steady 1.5 volt battery current budget of 10 microamps typical, that equates to about 87.6 milliamp hours total current drain per year. If we assume an alkaline AA battery life of roughly 5 years, that means the total battery current in 5 years is 5 times 87.6 equals 438 milliamp hours total. For a typical alkaline AA battery with 1500 to 2000 milliamp hour capacity, that means the standby current only consumes 22 to 29% of the battery capacity, leaving over 70% of battery current capacity to take moisture readings using the CPU run mode. Currently, there are 17 different quick solution designs with more to come. Just browse to this RENESAS website to obtain quick solutions, users' manuals, and app notes, schematics, bill of materials, PCB, Gerber files, and software project source code. Need help getting started? RENESAS is partnered with experienced independent design houses known as IDHs. These IDHs have experience in RL78 and other RENESAS MCU tools and software development. These design partners also have deep experience in various application segments and technologies. The map legend also highlights 17 different RENESAS Electronic America sales representatives who support the Americas. The RL78 MCU families are well suited to fit a wide variety of applications and markets based on the wide scalability, low cost, low power, and high system integration attributes available in RL78 MCUs. Some typical design targets are white goods, small appliances, industrial and building automation, medical home diagnostic equipment, personal healthcare devices, and consumer electronics. To summarize the 16-bit RL78 MCU family features, the RL78 family concept includes general-purpose LC drive, USB-enabled, inverter, lighting, and other application-specific MCUs. RL78 is true low power with 66 microamps per megahertz to 140 microamps per megahertz current drain in active mode, with 0.5 to 0.6 microamp standby current, including low-speed clocks and low-power timer operation. high-speed performance with up to 1.44 drystone MIPS per megahertz, or up to 44 drystone MIPS at 32 megahertz CPU operation, broad scalability in both code memory size and pin counts, high integration to enable system cost reductions, advanced hardware safety features, and IEC UL certified self-test library software to comply with IEC and UL 60730. Then extensive tool environments, third-party partners, and online resources. I want to thank you for attending this session.